Hello and welcome. We are now going to be doing lesson 5 from unit 4, and it's called Say It with Decimals. So, we are going to be looking at some things like how do we change a fraction to a decimal? What are repeating and terminating decimals? How do I change fractions to decimals to percents? And then later, we will work on word problems using fractions and decimals. So, for this first part, you're asked to see what do you notice and what do you wonder about these fractions and decimals. So, please go ahead and pause to type in your two things you notice and your two things that you wonder. Now, I've had students notice and wonder a lot of things on this particular page. I've had students notice that all of these fractions are actually 1 in the numerator. So every single one of them does. I've also had students notice that it goes 2, 3, 4, 5, 6. There's the 7, 8, 9, 10, and 11 for the denominators. I've had other students notice that some of these decimals stop or are short, I should say. So for instance, the ones that I'm underlining in blue here, they're rather short, whereas some of the other ones are kind of longer. So we are going to take a look at that. Um, One of the things that my students wonder that we kind of need to talk about before we get to these underlined ones is they wonder, well, how do you turn a fraction to a decimal? Like, how do you get that 1/3 is equal to 0.333333, going on and on and on, actually forever? So there's actually a really quick and easy way to do this. I'm going to start by showing you an anchor chart from your Google Classroom. So if you go to the anchor charts and videos section, there's lots of different things here. And the ones that we're going to be taking a look at are, well, here's fractions to decimals to percents. Okay, that's one. And actually, what else is on here? There's also changing fractions to decimals. So that's the first one we're going to look at. Um, I have a couple different charts here. We're going to look at this first one. And this one is basically going to tell us everything we need to know about that very first notice and wonder. So a lot of people ask, how do you change a fraction to a decimal? Well, it's right here. The first step is we divide our numerator by the denominator. So for instance, if we had 2/3 as the fraction, if we wanted to make it a decimal, we simply take that numerator, the top number of 2, and we divide it by the denominator of 3. So 2 divided by 3, and this is what we get. And likewise, we could change the fraction 5/8. Whoops, and I see a mistake on my anchor chart here. So we would take the 5 and we would divide it by the 8. So this should actually say 5 divided by 8 is equal to 0.625. So I'm going to keep this up because we're going to come back to it. So let's take a look here. Again, in the calculator, if I wanted to change 1/2, well, here's 1/7 actually. So if I wanted to, let's go ahead and do 1/2. I would do 1 divided by 2. And you'll actually notice that the Desmos calculator, or a scientific calculator, will write that as a fraction. So even though I typed in 1 divided by 2, the calculator actually reads that as a fraction, 1/2, or 1/2. So that's because they're equal, right? And which is also why we can get a decimal version. So that's how we change a fraction to a decimal. You always divide the numerator by the denominator, okay? Now, let's take a look. We have, remember I talked about these here in the blue. These are simple decimals, and we actually are going to call these terminating decimals because, well, they're terminating because they stop. The word terminate means to stop, right? So if we take a look again at this anchor chart, it's going to tell us terminating decimals, the numbers stop because there isn't a remainder. And I'll show you what that means here in a second. The other ones we see, well, some of them are repeating decimals because the numbers don't stop, and sometimes we start seeing a pattern in the numbers. So, for instance, if I come back to my Desmos, this stops because, let's take a look. If I did this in long division, it would look like this. 1 divided by 2, okay? And we know that 2 can't go into 1 evenly. So what we end up having to do is to take that 1 whole, and we're going to, if we're doing a long division, we're going to put our decimal here, but we can add zeros, and it's not going to change how much we're dividing, is it? 1.0 is still worth 1 whole. But now, now if I do 2, and now I'm going to divide this as a 10. So can you take 10 and divide it into 2 equal groups? Absolutely. It's 5, right? Because 5 times 2 is 10. And when we do that, we have no remainder. It's 0. There's no more numbers that we can get out of this decimal. And then, of course, this this decimal point comes up here. And this is our answer, right? So 1 divided by 2, which is 1/2, is also 0.5. And it's terminating because it stops. It doesn't, there's no remainder here, right? Whereas let's look at this, we're going to look at this 1/3, okay? I'm actually going to do 1/3 as a long division problem. So I'm going to close this up so I have a little more room. So over here, I'm going to do 1/3, and I'm going to do the long division. So I'm going to show you what ends up happening for 1/3. This is still going to be, I'm going to take my numerator of 1, and I'm dividing it by 3. So when I do this, well, again, if you take 1, you can't make any groups of 3 if you just have 1. So what we end up doing is we're going to use our zeros that mean nothing, but it's equal to 1, but we're going to use it to divide. So now, if I have 10, can I make any groups of 3? Yes, I can. I can make 3 groups of 3, right? And 3 groups of 3 gives me 9. So I'm going to put this here for my long division. Now, 10 minus 9, I have 1 left over. I have a remainder, don't I? So I can, to get a more exact decimal, I'm going to, again, add a 0. Remember, this is when we drop this guy down, and we're left with 10. So again, can we make any groups of 3 out of 10? Yes, we can make 3 groups. And that's going to, again, leave us with a remainder of 1, right? Because 3 groups of 3 is 9, so I can drop a 0 down. Are you getting the picture here of what's happening? Will this decimal ever stop? Because I can make 3 groups of 3, which is 9. What's going to keep happening? I could put, no matter what, I can add as many zeros as I want, but this thing is never going to stop, right? So we call something like that, it's not a terminating decimal. And in this case, it's repeating, because what's happening? We're getting threes. 3, 3, 3, right? So if we wanted to actually be a mathematician and write this like a mathematician would, we would write 1/3 as a decimal. We would actually write it like this to be more precise. It's actually equal to 0 point repeating 3. We actually put a line over the 3 since the 3 is repeating, okay? So terminating, because it stops, repeating because it keeps going, and it's got a pattern in the numbers that are coming up when we divide, okay? 0.25, terminating, right? It stops, we can tell, it doesn't have anything behind it. Same thing, terminating. Okay, now, is this terminating? No. But here's my question, is it repeating? Does it have a pattern? And this is where this one gets a lot of students, because they look at this and they go, no, it ends in a 7. Okay? This isn't true, because that's just because the calculator rounded this last place from a 6 to a 7, right? This is actually 0.1, and then this 6 just keeps going on and on and on and on and on. It never stops. There really isn't a 7 at the end, is what I'm trying to say. Okay? This is a repeating decimal. The way we write it, so like if you ever see a number at the end like this, and it's like one higher, and you've seen all these, you know it's repeating, okay? The way a mathematician writes 1/6 as a decimal is 0 point, whoopsies, 1 repeating, 6. Notice my repeating part only goes over the 6 because does this 1 repeat ever? No, it doesn't. So it's just over the 6. Okay? Likewise here, we see repeating 0, 9, 0, 9, 0, 9, 0, 9. So what's the pattern? Well, 1/11th, if you're a mathematician, you're going to write it as 0.09, or repeating 0.9. And notice I'm putting that line over the 0 and the 9 because they both repeat. Okay? Terminal or terminating, terminating. And then this guy is also a repeating decimal because that 1 is going on and on and on. So let's kind of sum up what we've learned from this Notice and Wonder, right? We learned that some decimals are called terminating decimals because they stop. There's no remainders, like 1/2. Some decimals are repeating because there's always going to be a remainder. Okay? Some decimals, and actually I should say this, we also remember that we can convert a fraction to a decimal by dividing the numerator by the denominator. Now, some of you might be looking at this one and going, but she never went over this one. Well, let's take a look at this one because it's really unique. If we take a look at, I'm actually going to type this guy up in the calculator. So we're going to do 1/7. 1 divided by 7. And here's what I'm getting, right? Now, if we look here, it looks like the end of this one is different from the end of this one, right? This is actually a 2, okay? For 2. And then it said a 9, okay? This is actually a repeating decimal as well. It's just got a really long list of numbers repeating. So this one should actually, as a mathematician would write it, it would be 0.1287, and then all of that continually repeats, believe it or not. So then it would go 142,857. And then after that, it would just start again, 142,857. So that's like a really long repeating decimal. But I think we're ready to move on. Okay, so now what I need you to do is to look at this here. It says, when looking at the problems on the previous slide, Sam said, wow, the number for 1/11th is bigger than the decimal for 1/5. What do you think? So Sam's saying that this number here for 1/11th is larger than the number for 1/5. So I want you to go ahead and type in, which one do you agree with? Sam? Do you agree with Sam or do you disagree with Sam? If you're not sure, check this video out. Okay, so when we're looking at decimals, this is really asking us to compare them. Which one's larger? And so we have to think about what that word bigger means in this case. When we're asking whether a number is bigger or smaller, normally we're thinking about which one's worth more, right? So like if I gave you the number, well, I'm going to use 11 and 5, just the number 11 and 5. If I give you 11 and 5, which one's bigger? Oh, you would say 11 is bigger, right? Okay, which one's bigger? 9, or 2? Oh, 9 is bigger. It's worth more, right? Well, if we're looking here, Sam is saying which is larger, 0.2, which was 1/5, or 0.09090909. Okay? Now, Sam said it's larger, and I'm thinking Sam is thinking that this number is bigger because it's got more numbers. It's longer, isn't it? It's definitely longer. However, 1/5 is actually larger than 1/11th. Okay? There's a couple ways we can look at that. We can see this. I put these up, I lined them up as though we had a place value chart. Okay? So, place value chart simply takes numbers, and I'm going to put that decimal in there, and takes their place value into account. Okay? So, here's our ones, here's our tenths, here's our hundredths, here's our thousandths, and here's our 10,000ths. Okay? Now, the way numbers work, I'm going to put these on our place value chart. If I were to put the number, I'm just going to put 9 and 2. If I were to put these on the place value chart, and let's just compare the 9 and the 2, you knew 9 was larger, right? And we know it's larger because if you have 9 ones and 2 ones, well, certainly 9 is more than 2, right? Now, here, if we're just comparing these two up here, they both have 0 ones. We go to the tenths now. Well, this one has 2 tenths and this one has 0 tenths. So even though there's a 9 here and it's longer, this doesn't matter because these 2 tenths are more than this number doesn't even have a tenth. Okay, so therefore 2 tenths is actually larger than the 0.090909. So when we look at this problem, the answer here is that I disagree with Sam because 1/5 is actually larger than 1/11th. All right, now your job is going to be to sort the fractions into two stacks, terminating decimals and repeating decimals. So this is where we're using our knowledge from that first page. How do we know if a decimal is repeating? Well, the very first thing you have to do is put it in a calculator. You have a calculator, so this should be easy. So 3/10 here, I actually don't even need to put this into a calculator because I remember that this is terminating because 3/10, gosh, it has what I call a decimal denominator because there is the tenths place. I know that this is 0.3. So I would say this as 3/10 because the 3 is in the tenths place. So I already know that this terminates. It doesn't keep going. I'm actually going to look real quick. Are there any other decimal denominators like tenths, hundredths, thousandths? Okay, I don't see any more. So the other one, okay, I'm going to look at these fifths here. All right, so, well, yeah, let's look at 1/5. So literally, I'm just going to start putting these in the calculator. 1 divided by 5, 0.2. This is terminating because it stops. Let's do 5/6. 5 divided by 6, 0.8. Okay, this is not terminating. That is repeating. The 3 is repeating in that one. So 5/6 goes there. All right, let's do 4/11ths. Okay, there we go. 0.36 or 0. Repeating 36. This is a repeating decimal. We can see it's going, there's a pattern, 36, 36, 36. All right, let's do 7/5. So 1.4 that stops. It's terminating. Okay, 3/4, I just know. This is a decimal you need to know. 3/4 is equal to 0.75. Okay, a lot of people like to look at that and say if you have 3/4 of a dollar, you have 75 cents. Well, that's how we write 75 cents. If you don't believe me, you can put it in the calculator. But it is 0.75. All right, let's do 7/15. Whoops, I didn't mean to add you. Repeating, even though that 7's there, we have to remember that that's just being a 6 that's being rounded up. So this actually comes here. Okay, 2/3. This also is a fraction you need to get to know. It 2/3 is, whoops, let's see, 2 divided by 3 is going to be 0.6 repeating, right? Remember, same thing as up there. So that's kind of a common decimal you might learn. All right, let's see, 7/9. Okay, again, we have repeating. Okay, 3/8. Okay, very good. So there are our answers for that one. Okay, this is just to check your work. Here's the chart. This is in case you made any mistakes. This might help you remember what you need to do. Let's check just to make sure. I think we got it right, but we'll see. All right, cool. All right. This is where somebody is approximating pi as a decimal, 3.14. And then another person is approximating pi as a fraction of 22/7. If any of you have forgotten, pi is a constant number. We used it in our circle unit. So which one of these is is closer to what pi actually is? So go ahead and do what you think, and then we'll go from there. Okay, so for this one, we're just going to take a look. I'm actually going to take the 22/7 and I'm going to do long division to turn it into a decimal. So again, it's a fraction. I do the 22 and I'm going to divide it by 7. And hey, look, this actually goes in 3 times, right? Because 3 times 7 is 21. And I have it left over. I have a remainder. So I'm going to continue my division. I'm going to put a 0, drop it down. Okay. Now, okay, I know that there needs to be a decimal here. And I also know that 7 goes into 10 once. And when I do that, I'm also going to have a leftover. So I'm just going to keep doing my division. Okay, I know this would be 4 because 4 times 7 is 28. And I was trying to divide 30 by 7. If I do that, I'm going to get another leftover, which means I can drop down another 0. And I know that 7 goes into 40. How much? 5 times. And I know that there's going to be a decimal, or I know that there's going to be a leftover, right? Because that's 35. So there's going to be 5 leftover, and it's going to keep going on and on and on. Pi is actually a number that does go forever. There is no actual number that it just keeps going. There's always going to be a remainder. And what's even more interesting about pi is that it never repeats. It's not a repeating decimal, and it doesn't stop. Nobody's found an end to pi. So if we kept going with the 22/7 and we kept dividing, we'd be getting closer and closer to what pi actually is, right? So what this is telling me is that if we just use 3.14, it's actually not as accurate as if we use this fraction version, because the fraction version, technically, we could keep going on and on and on, and it's actually going to represent pi. Okay? So this is actually a better approximation for pi. Okay, so go ahead and I want you to type in something here. You tell me, what do you think is important to remember about terminating and repeating decimals? If you need to, go back to this chart to help you, but go ahead and type something in for that. And now we're going to look at fractions to decimals to percents. So you have to be able to do this. And there are some resources in Google Classroom under the anchor charts and videos. You want to look for fractions to decimals to percents. So there's actually two different sections under the anchor charts and videos. Okay. There's and actually I'm going to go back to this just so we can see it better. Okay, there's two. There's fractions to decimals to percents, and there's just fractions to decimals. This is the one where we start adding in percents. So there are a bunch of different charts in here. There's even a video that will help you convert between fractions and percents and decimals. So just to kind of remind ourselves here, we just learned how to go from a fraction to a decimal. We divide the numerator by the denominator. And if we have a decimal, it's easy to make a percent because all we do is multiply that number by 100. So if I said change 3/4 to a percent, it's actually 75%. Okay, we can change it to a decimal and then take the decimal and multiply it by 100. Some people like to just move the decimal over twice, want to do multiplying by 100. So they would say, oh, look, we can go once, twice, and 0.75 turns into a decimal of 75, okay? You might want to go backwards, and to go backwards from a percent to a decimal, you just do the opposite. You would take 108, or the percent, and you would divide it by 100 to make it a decimal, which makes sense because dividing is the opposite of multiplying. So let's take a look at what we need to do for this. We have a card sort, and in the card sort, we have to match up equivalent fractions, decimals, and percents. So I want you to try to go ahead and do that. It also says round the percents to the nearest tenth of a percent. So I'm taking a look here, and we've got lots of different things. So you go ahead and get started, and then pause, and then come back when you're ready to see how to do this, or if you need help. Okay, so I'm actually going to start out by matching my decimals and percents first, and then I will find the fractions that are equal to those. So right off the bat, I'm looking and I see at this top we've got 0.25, and I know that if I take a decimal and I multiply it by 100, so you can try that out, 0.25 times 100 equals 25. So I know 0.25 and 25% actually go together. Again, there is a quick trick for those of you, if you don't want to have to use the calculator. There's a trick. If you have a decimal and you want to multiply by 100, all you do is you take wherever the decimal point is. Let me get rid of this, and then I'll show you to the side. Well, actually, I'll show you right here. So if we have 0.25, to change it or to multiply it by 100, you can take this decimal and move it over twice. And the way I remember that is it's one for each 0 and 100. And that's a trick that people use. So 0.25 times 100 is 25, or 25% in this case. Okay. All right, so let's see here. What else? I'm matching up my percentages and my decimals. So I'm just going to find a decimal. So I have 0.5. I'm going to multiply that by 100. So 0.5 times 100, and I get 50. So now I'm going to look for 50%. There it is. So I know that's there. Whoop. Okay. Oh, and you know what? I personally know that 1/2 is 0.5. So I am going to match that just because they're right there. Remember, this is a very important fraction. So if you didn't know it, all you have to do is go ahead and in here and do 1 divided by 5 or 1 divided by 2, and you will find that it is 0.5. Okay, so let's see here. I'm going to do, let's do this, 0.04. I'm going to take that. Whoops, I guess I need to 0.4, and I'm going to multiply it by 100, and I get 4. So I know this is actually 4%. There it is. Okay, how about 1.75? Ooh, that's different than the others. So 1.75 times 100, 175%, right? There we go. Okay, 0.4. I'm going to use the little trick that I did over here. Instead of typing it in, I take my decimal and I'm going to move it over twice. So let's see. So that goes once. Wait a second. There's not even another number here. So how do I move it twice? Well, this is where we got to put a 0 in. For those of you who remember from the long division, if I put a 0 on the back of this decimal, it doesn't change it. It's still 4/10. Adding any, I could add a million zeros on the end, and it's still worth the same amount. So 0.4 times 100 is actually 40. So I'm going to look for 40%. Okay. And okay, we still have something because I got this. Oh, this one sticks out, doesn't it? It's the only decimal left. And so I have to remember this is a repeating 6. So 0.66666 and it goes on forever and ever and ever. So if I did put in 0.66666 times 100, I actually get this, but remember in my directions it says round percents to the nearest tenth. So the tenths place is right here. It's the first one behind the decimal. So that 6 is going to be rounded to a 7 since it had a 6 behind it. So this actually matches up with this. Okay. So now I'm just left with all these fractions. So all I have to do for these, there's a couple of different ways. I'm actually going to start with 2 that I don't need to even use a calculator for. 4/10, because tenths is a decimal place, the tenths place, right? So if I literally I'm going to start by writing what I'm seeing. 4/10 means that I have 4 in the tenths place. This is the tenths place, right? So 4/10 is 4/10, right? So I'm going to look, which one of these has 4/10? Okay, this is close, but this is actually the hundredths, not the tenths place. So I'm looking, this one has 4/10. So I know this matches here. And I'm actually going to go to 400s because we found it, right? Again, this is a decimal denominator, meaning there is a hundredths place. So I know to write 400ths, if I were to write it out, I have to go, well, tenths place, hundredths place. So there's 4 in the hundredths, and we do put a 0 in here, and we have to show that there isn't any tenths in this particular decimal, right? So 4/100ths matches up here. Okay, let's see, where are we at? What's next? How about 1/4? Again, this is one that you should know, 1/4. If you don't, that's fine. You'll get to know it eventually. So 1 divided by 4 is 0.25. So that's going to go here. So 1/4 is the same as 25%. Okay, 7/4. Now, I have a guess. 7/4 is actually more than 100%. Percent means out of 100, okay? And so if I have something like this is over 1 whole, meaning 7/4, if I go ahead and divide it, it's worth more than 1, right? Because the numerator is bigger than the denominator. So therefore, that tells me I already knew that this has to be more than 100%. And there's only one that is more than 100%, and it's this one, right? And it does, you can see that it lines up, that 7/4 is the same as 1.75. I only have one left, but let's double check. 2/3. 2 divided by 3. Indeed, it matches here. So these are all the matches. And this is actually part 1 for our very first part of lesson 5. And that's all we're going to be doing today.